Welcome back. Hi everybody. In this session we are going to discuss kinetic theory of gases, worksheet questions. Let us enter. Under which of the following conditions is the law PV equal to RT, PV equal to nRT obeyed most closely by the gas? HTLP. Let me change the color. HTLP. It's a memory aid. HTLP. HTLP. You can assign a name for them so that you can easily memorize. High temperature, low pressure. High temperature, low pressure. Option C. Okay. So HTLP. Memorize like that. Ideal gas equation works at HTLP. Pressure versus temperature graphs of an ideal gas are as shown. Okay. Pressure versus temperature graphs. Okay. Wrong statement. Identify the keyword. Wrong statement we want. Wrong statement. Density of gas is increasing in graph. Density is increasing. Pressure. Okay. In graph 1. PT graph it is. At constant temperature, pressure is increasing. See, PV is equal to M by M RT. M by M RT. P is equal to density by M RT. At constant temperature, R of course constant. As P increases, D also increases. Yes, first one is correct. First option is correct. P is proportional to D only at constant temperature. Correct only. Now let us think about the second option. Density of the gas decreasing in the graph 2. Here in this case, temperature is increasing. See, P is constant is equal to D by M constant, R constant, T is increasing. See here in this, T and D are inversely proportional. If T increases, obviously D value should decrease, right? So it's a density is decreasing. Correct only. So as temperature is increasing, obviously density decreases. This is also correct. So this is correct. This is correct. He is asking wrong statement. Density of a gas is constant in the graph. In the graph 3. 3. As T is increasing, P is also increasing. So T increasing, P increasing. Density may be constant, may not be constant. We can't tell anything like this. May be constant, may not be constant. So if he use may, then that is also a correct statement, but he didn't use the word may. So maybe the third one is likely wrong answer, wrong statement. Yes, next. If pressure of CO2 gas in a container is given by P is equal to RT by 2B minus B minus A by 2, 4B square, the mass of the gas in the container. We'll do this problem like this. This equation can be compared with Van der Waals equation so that number of moles will come as N equal to 1 by 2 and that is equal to M by M, where M is equal to, we want mass only, right? So M by 2, what is this gas? CO2 gas. CO2 is 44 grams, 44 by 2, that is equal to 22 gram. Yes. So next. Consider an ideal gas is closed in a container 300 Kelvin. T1 is equal to 300 Kelvin. The container is then heated so that the average velocity of the particles of the gas increases by a factor of V dash is equal to 4 V1. Okay. What should be the final temperature? T2 equal to how much? See, average velocity V is proportional to root T. So I can call it as V dash by V is equal to root over T dash by T. So V dash by V is 4 is equal to root over T dash. I have to find T 300. So squaring on both sides, 16 is equal to T dash by 300. So T dash is equal to 16 3s are 4800. Here 4800, even Kelvin है ना? Okay, Kelvin. So 48 closest number 46 45 Let me check it. Anything I missed? Almost all calculation and everywhere correct only. So okay, this is in degrees Celsius and we got in Kelvin. So minus 273 we need to do. That means here is 7 and this is 10. 10 9. 9 minus 7 is 2 and this will be 7, 5 and 4, 5, 2, 7. Yes. So don't get disappointed even after watching the option. Sometimes we may not think in a different way. Okay. See how I got tense? Because I did everything correct, but I didn't find the answer correctly. That means some changes. What kind of changes? So that you have to think with some pleasant mind. Okay, I'm also doing like you only. Yes. Next, a cylinder contains 10 kg of gas. M is equal to 10 kg. Pressure P is equal to 10 to the power of 7 Newton per meter square. The quantity of gas taken out of the cylinder if final pressure is P1. P2 is equal to 2.5 into 10 to the power of 6 Newton per meter square will be the temperature of the gas constant. And cylinder contains 10 kg. So volume is also obviously constant. So some gas is removed. Delta M is equal to how much? That's what. So I told PV is equal to M by MRT is a preferable formula, not PV equal to nRT. M by MRT will be good. So we'll write for two parts. P1 by P2 is equal to volume same. M, one's mass is M, others one's mass is M plus M minus delta M because something is removed from that. Some gas is removed. So M minus delta M. M minus delta M into R is same. Gram molecular mass same, T is same. So P1 is equal to 10 to the power of 7 and this is 2.5 into 10 to the power of 6 and M is equal to 10 kg. This is 10 minus something delta M. So 110. 10 minus delta M is equal to 2.5 into 10 to the power of 7 by 10 to the power of 7. 10 to the power of 7, 10 to the power of 7 will go. So 10 minus 2.5 is equal to delta M. So delta M is equal to 7.5 kg. What is this? Final removed mass. Yes. Next. As per kinetic theory of gases, which of the following statements are true? True. Temperature of a gas is a measure of average kinetic energy of a molecule. Temperature of a gas depends on the nature of the gas. Heavier molecules have lower average speed. Lighter molecules have lower average speed. So among these, which are correct, that we have to identify. Yes. So among these options, temperature of a gas is a measure of average kinetic energy of a gas molecule is true only. Temperature of a gas depends on the nature of the gas, need not be. Heavier molecule average is square root of 8 RT by pi m. So V inversely proportional to root over m. So heavier one will have less average. So this is true only. This is true. Obviously this is wrong and this need not be. So 1 and 3 are correct. 1 and 3 this option. That means it is a C option. Yes. Next. If a gas has n degree of freedom, then the ratio of Cp by Cv is equal to F plus 2 by F. That means n plus 2 by n. Either like this or 1 plus 2 by n. So whichever is given, that you can take. So option A. Okay. Next. And an ideal gas is this is kinetic theory of gas is a small chapter and will give you a guarantee question. So concentrate. An ideal gas in a closed container is heated so that the final RMS speed of the gas particle is increases by 2 times. Final RMS speed is increases by 2 times. If the initial temperature of the gas T1 is equal to 27 degrees Celsius plus 273 is equal to 300 Kelvin. Final temperature of either gas T2 is equal to how much? Yeah, this is V2 by V1 is equal to root over T2 by T1. V2 by V1 is 2, that is equal to root over T2. Don't know. T1 300. So 4 is equal to T2 by 300. So T2 is equal to 1200 Kelvin minus 273, roughly 300. If you subtract, it will be 900. 900 plus terms 27, 927. So 927 degrees Celsius. Next. The RMS velocity of a gas at certain temperature is root 2 times, at certain temperature is root 2 times that of the oxygen molecule at the certain gas. Oxygen RMS velocity is root 2 times oxygen at the same temperature. This gas can be. So RMS velocity formula is square root of gamma RT by M. No, 3RT by M only, right? By gamma RT by M. This is not velocity of the sound, right? So 3RT by M. 3RT by M of the gas. That is equal to root 2 times of square root of 3RT by gram molecular mass of oxygen. Oxygen. O. O2. It will be in O2. O2 means O2. O means 32. 32 2s are 64 gram molecular mass. Now calculation followed. Yeah, it is O2. O2 is not 64, it's 32, right? Yes. O2. O is 8. 8 2s are 16, 16 2s are enough. 64 not required, 32 only. Yes. So it is 32. So 3RT gets cancelled and squaring on both sides. 1 by M is equal to 2 by 32. That is 16. M is equal to 16. Whose mass is 16? This is just 2 only. This is just 4 only. CH4 12 plus 4 is 16. CH4 is the answer. At what temperature the mean kinetic energy of oxygen will be same as H2 molecule at minus 273? T of oxygen question mark. T of hydrogen is equal to T of hydrogen minus 73 plus 273. It will be 200 Kelvin. So at what temperature the mean kinetic energy? Mean kinetic energy means average kinetic energy. Average kinetic energy 8RT by pi m. So V is equal to mean, root mean square or average. So this should be very carefully thought, right? We need to read the question carefully. He is not asking velocity, he is asking kinetic energy. That means kinetic energy of every molecule at a given temperature is same only. So why am I thinking about velocity? Kinetic energy. Kinetic energy is same for all the gases at a given temperature. He said kinetic energy same means the temperature must be same. As K is same, temperature must be same. That means minus 73 degrees Celsius only. Good concept it is. Next, two boxes are at the same temperature. The first box contains gas with molecular mass M1. First box contains gas with molecular mass M1. Okay, and RMS speed V1. And the second box contains molecular mass M2 and average speed is V2. This is average speed. Average speed. This is RMS speed. Wow. RMS speed. Then if V1 is equal to 3 by 2 times of V2. I don't want to use point numbers. I want fractions. Then M1 by M2 is equal to M1 by M2 equal to. So see, we'll go for RMS velocity expression. Square root of 3RT by M1 is equal to, at the same temperature is same, this is C, T, this is also T, that is equal to 3 by 2 times of, this is RMS velocity and this is mean velocity or average velocity, that is square root of 8RT by pi m. So on squaring on both sides, RT will go, this is just 3 by M1 and this is equal to 9 by 4, 8 by pi M2. What he wants? M1 by M2 he wants. M1 by M2 is equal to 4 will go 2 times, 4 will go 2 times and 3 will go 3 times. So this is 3 to the 6, right? So m1 by m2 is equal to pi by 6, 3.14 by 6, that is equal to almost 0.52. So it will be C option. Yes. Next, the RMS speed of oxygen and room temperature is about 500 meters per second. RMS oxygen is equal to 500 meters per second. And the RMS speed of hydrogen at the same temperature is about RMS velocity hydrogen at the same temperature is equal to this question you can use RMS velocity formula, V equal to root over 3 RT by M. Okay, so it depends upon gram molecular mass. So V of hydrogen by V of oxygen is root over, this is hydrogen mass I have to write, and here is oxygen mass I have to write. The VH I have to find, and V naught 500 into root over m naught is 8 2s are 16, 16 2s are 32. Why? Because molecular mass only you have to consider. 8 is for oxygen. Okay, this is atomic number. So mass number is 16 and then O2 32. So that 32 I have to use. MH H2 2, yeah. So 16 4s 5 into 4 2000 joule meter per second. The number of vibrational degrees of freedom for a diatomic molecule, vibrational degree of freedom at low temperatures is only 1. Yeah, not total degree of freedom, only vibrational he is asking. The respective speeds of the 5 molecules are this. The ratio of their RMS velocity and the average velocity will be lengthy question. You need to do RMS velocity, average velocity. VRMS, I'll write the formula. That is 1 square plus 2 square plus 3 square plus 4 square plus 5 square by 5 and the root RMS is this one. And V mean or average, V mean is equal to 1 plus 2 plus 3 plus 4 plus 5 by 5. So dividing one with other, why should I waste time? You can, right? So this is the answer. Next, the pressure of a gas is proportional to sum of kinetic energy and potential energy. Potential energy only, kinetic energy only, none of the above only. Read the question again. Pressure of the gas is proportional to, from kinetic gas equation, we can say that pressure of a gas is directly proportional to its kinetic energy. So option C could be the correct answer. Yes. Next, cylinder has a piston at temperature 30 degrees. There is all round clearance of 0.08 mm between the piston and the cylinder wall. If internal diameter of the cylinder is, let me write, temperature T1 is equal to 300 degrees Celsius plus 273 if possible Kelvin, or I will use this one only, and available length L equal to 0.08 mm. Okay, mm units must be checked, and internal diameter D is equal to 15 centimeters, so that we can find out volume. Okay, units are different. What is the temperature at which the piston will fit into the cylinder exactly? So there is a gap and it must fit into the gap exactly. Alpha of the piston is equal to 1.6 into 10 to the power of minus 5, and alpha of the piston and one is cylinder. So first one can be cylinder, next one can be piston. That is 1.2 into 10 to the power of minus 5 per degree Celsius. So have to think about. See here, increased gap must be equal to the cylinder piston's gap. See, this is cylinder, this is piston. This gap is, overall gap is 0.8. Overall gap is 0.8. That means I can call it as this one and this one are differed by 0.8 totally. So we have the final length whatever L final is equal to L initial into 1 plus alpha delta theta, and that is L initial into 1 plus alpha delta theta. This must be written for piston, this must be written for cylinder. So whatever, I'll write the substitution and you can simplify this. So piston, cylinder first, later piston, cylinder, piston. That is cylinder. cylinder 0.08 into 1 plus 1.6 into 10 to the power of minus 5 into delta theta is equal to 150. Both should be in mm, so it is 150 mm. So into 1 plus alpha 1.2 into 10 to the power of minus 5 into delta theta, yeah. So on solving this, you can get theta roughly 300, actually 273 plus that 30 will come. So around 305 degrees Celsius will come. Yes. Choose the wrong statement to complete an ideal solenoid has. Ideal solenoid, the turns widely separated. Wrong statement. Turns closely wound. The length is very much greater than the radius. Length is very much greater than the radius. Wrong statement. The magnetic field inside is almost uniform. See, he is asking wrong statement, not the correct statement. So the wrong statement is option A. They must be closely packed so that uniform field will be produced. So wrong statement is A. Gas at volume 251 centimeter cube, V1 is equal to 251 centimeter cube, at T1 is equal to 20 degrees Celsius and pressure is 78 centimeter of Hg. Find the volume at NTP. Volume is equal to question mark, temperature is equal to 273 degrees Celsius, right? 273 Kelvin, right? By 273 degrees Celsius. So we have to do in sum in Kelvin, right? It must be done in Kelvin. And this is also plus 273 we have to add. Then Kelvin will come. Kelvin number 293, 293 Kelvin. And pressure P is equal to 78, 76 centimeter of Hg is the pressure. So use P1 V1 by T1 is equal to P2 V2 by T2. So whatever he want you can find. 78 into V1 251 by T1 293, that is equal to here 273 and this is 76 and into V2. Not major difference, almost all very close only will come. So yes, not much difference because these two are not changed so much and that is also. So V2 can be established as 263.8 centimeter cube. Next one. An insulator system contains 4 moles of an ideal diatomic gas at temperature T1. Number of moles 4. Diatomic gas F, degree of freedom is equal to 5 at temperature T. When a heat Q is supplied to the gas, 2 moles, N equal to 2 moles of the gas dissociate into atoms of temperature, dissociated into atoms. That means diatomic will become monoatomic. Then degree of freedom will become 3. And number of molecules will be N is equal to 4. Why? Because 4 moles of monoatomic, because 2 moles dissociate, so automatically 4 moles it will be 4 moles and remaining 2 moles of diatomic will be left out. Temperature constant. Then the relation between Q and T is okay. See, initial potential, initial internal energy EI is equal to half NFRT, half 4 5 RT. So that is equal to 2 into 5 into RT, that is 10 RT. This is initial energy. Finally is, see, 4 moles of mono are there and remaining 2 moles of di are there. So half N F value 3 RT plus half 5. Here something is missing. What is that missing one? Let us write slowly. What is the formula? Half NF RDT. Half N F is 3 RDT RT. Okay. Plus half Number of moles are 2, degree of freedom 5 into RT. 2 gets cancelled, 2 will go 2 times. So 3 is 6 RT and this is 5 RT. So total 11 RT. Yeah. Now heat supplied is equal to change in internal energy. 11 RT minus 10 RT. 1 RT only. 1 RT only. That means first option only. Oh yeah. Next. The average translational kinetic energy of a molecule in a gas becomes equal to 0.69 at temperature about Boltzmann's constant is so. Is that EV? Electron volts? Okay. Yeah, that can be electron volt. So, average kinetic energy Ke is equal to 3 by 2 kBT, Boltzmann's constant into temperature. This is 0.69 into 1.6 into 10 to the power of minus 19 joule. 3 by 2. Boltzmann's constant 1.38 into 10 to the power of minus 23 into temperature. So on solving for temperature, I may get Kelvin temperature will come. So you need to convert. You will get in Kelvin temperature minus 273 how to do. So that roughly you may get 5060 as I have the calculated value. I don't want to waste the time. This is the logic. Next. Air is filled at 60 degrees Celsius in a vessel of open mouth. Air is filled at 60 degrees Celsius in a vessel of open mouth. T1 is equal to 60 degrees Celsius plus 273 Kelvin. And the vessel is heated to a room to a temperature T so that 1/4 part of air escapes. Okay. Assuming the volume of the vessel containing constant. Oh, fine. So T2 is equal to how much? Initial mass of the gas you have to take m, final mass of the gas, so that 1/4 part escapes. So final mass will be 3/4 of m. That is the magic. 1/4 left from the chamber. That means 3/4 present in that. So we have PV is equal to m by m RT. Open mouth, so atmospheric pressure only will be maintained. Pressure same, volume of the container same. M and T must be related. So T1 by T2 is equal to inversely proportional M2 by M1. So T1 is equal to Kelvin only you need to use. So 333, 333 correct? 273 plus 60. This is 333 by T2 is equal to M2 is 3 by 4, gets cancelled. So T2 can be solved for, so 111 into 4, 111 into 4 is 444, minus 273 will give you correct number, that is 1, and this is 14 minus 7, and 1 will go 3, 171 degrees Celsius, yeah, D option. That problem is not easy. Why? Because the Kelvin conversion is there, mass left is there, so automatically mass present you have to take. Cylinder fixed at capacity V is equal to 67.2 liters containing helium gas at STP. STP temperature 273 Kelvin and pressure is equal to atmosphere pressure, 1 atmosphere pressure. And the amount of heat needed to raise the temperature of the gas of the cylinder by 20 degrees Celsius. Delta T is equal to 20 degrees Celsius. The amount of heat needed. He didn't mention the condition whether it is at constant volume or pressure. Then you have to take pressures one only. dq is equal to NCP dt, and it's a helium gas. Helium gas means you need to have what's that? Diatomic, monoatomic, He, helium gas, monoatomic, mono. So gamma is equal to monoatomic 5 by 3, mono 5 by 3. And amount of heat needed, N value, number of moles, 67.2 liters contains how many moles? Number of moles is equal to 67.2 by 22.4. How many? 2 times 4 only, 3 times around 3 moles. So N is 3, Cp is equal to 5R by 2, 5R by 2, and dt is equal to 20. This will go 10 times. So 3 5s are 15, 15 8s are 15 into 8.3 into 10. So 120, 1200 around. 1200 around, and 0.3 is also there. Any other calculation? 15 into 8. 120 only. 120 point something. So we need to. So it's going to become 1200 joules roughly. But here I took Cp, right? As he didn't mention, I considered Cp. But on reading, because no option, I have to read the question again. On reading the question, a cylinder of fixed capacity, maybe it's a constant pressure process, volume process, because it's using a word fixed capacity. So it's my mistake. I shouldn't do this one. I have to go for dq is equal to ncv dt. Why? Because fixed capacity. So n is equal to 3 into, this is 3r by 2 into 20. So 20 will go 10 times. 3 3s are 9, 90, 9 in 90 into 8.3. 9 8s are 72. 748 is there. Okay. Correct answer. So the correct answer is this one. Pressure of an ideal gas at constant volume is proportional to pressure of an ideal gas at constant volume. PV is equal to nRT. Pressure at constant volume is proportional to temperature. Okay, force between the molecules, average potential energy of the molecules, total energy of the gas, average kinetic energy of the gas molecule. Based on the kinetic theory of gases, if you think about it, will become kinetic energy of the gas molecule. So option D will be the answer. Gas mixture contains monoatomic and diatomic molecules of 2 moles each. Gas mixture contains monoatomic, diatomic 2 moles each. Mono n equal to 2, di n equal to 2. The mixture has a total internal energy. Mixture has total internal energy is equal to, so half NFRT in terms of T only, plus half NFRT. So here half common, 2 moles common, RT common, only degree of freedom. This is having degree of freedom 3, this is having 5. So it is 8. So 8 RT. 8 RT. 1 mole of oxygen, N is equal to 1, O2 gas, heated at constant pressure starting from temperature T1 equal to 300 Kelvin, plus 273 should be added. How much energy must be added to the gas to heat double its volume? Q needed to have V2 is equal to 2V1. Double its volume. To double its volume, he said constant pressure. Yes, constant pressure. To double its volume, temperature must be doubled. Temperature must be doubled. Constant pressure process. So dq is equal to ncp dt, and n is number of moles 1. Cp value is oxygen gas, diatomic gas 7R by 2 into dt. T1 is equal to 300 Kelvin. Double its temperature means T2 equal to 600 Kelvin. The difference is 300 Kelvin. That means 150 into 7R. 150 into 7R. So R value in terms of R only it is. 150 into 7R. 70, 7 5s are 35, 1050 na. Okay. 1050R. Next. Mean energy of a molecule of an ideal gas is, mean energy of a molecule of an ideal gas is it 1 by 2 kT or 3 by 2 kT or the other option? Yes, you are right. That is 3 by 2 kT. That is 3 by 2 kT. A bicycle tire is filled with an air having pressure P1 is equal to 270 kilopascals, 10 power 3 pascals, at temperature T1 equal to 300 Kelvin. The approximate pressure of the air in the tire when the temperature increases to T2 equal to 36, 9 degrees Celsius, it is 309 Kelvin. This is 7. This is 36. What is the difference? 9. So 9 you add here. So time can be saved, right? And he is asking pressure. P2 equal to volume same. Volume same. Sir, tire expands. No, sir. That is negligible. Volume same. So this one is nothing but P1 V1 by T1 is equal to P2 V2 by T2. And V2 and V1s are same. Just P1 is equal to 270 kilopascals only will do. Temperature is 300 Kelvin. And this is 309. This is 309. And this one I have to find out. P2 I have to find out. So P2 very little change it will be. Not so much. 309 by 300 into 270. So it will be equal to 278. Will be equal to 278. Initial 270, 278. Very little change. So the temperature of an ideal gas increased from T1 is equal to 120 to T2 is equal to 480 kelvins only. And at 120 Kelvin, root mean square velocity of a gas molecule is V. Here is how much? So root mean square velocity, right? So V2 is equal to V1 of square root of T2 by T1. T2 by T1, 480 by 120. 120 4s are. So 2 times 2V1. 2V1. Not 20, it is 2V1. 2V1. Yeah. Next. The ratio of specific heat Cp by Cv equal to gamma in terms of degree of freedom. Degree of freedom is gamma is equal to F plus 2 by F. Sometimes it is asked as 1 plus 2 by F. Or F is equal to N also you can. So the formula will become 1 plus 2 by N. 1 plus 2 by N. Option B. Yeah. Next. Water of volume V is equal to 2 liter. In a container is heated with a coil of 1 kilowatt at par is equal to 1 kilowatt and temperature T1 equal to 300 Kelvin and the lid of the container is open, that means pressure same. Energy dissipated at a rate of dq by dt or dh by dt is equal to 16 joule per second. And now how much temperature will rise from how much time? Okay. Time t is equal to question mark temperature 27 to 77 roughly 50, right? So T2 is equal to 50. What 50? 50 change, so 350 Kelvin. Yeah. And given specific heat of water is 4.2 kilojoules, that everybody knows. So yeah, I made one small correction here, that is 160 joule per second, it is not 16. So mc delta theta is equal to power produced into time minus power dissipated into time. Power produced, power dissipated. So net heat used by it. M is equal to m. Volume 2 liters. Okay. So what is that? Water. So 1 liter is equal to 1 kg for water. So 2 into specific heat is 4,200 I can use. Into temperature difference is 50 I can use. Is equal to time can be taken common. So power produced 1000 minus power dissipated 160. So time t is equal to roughly 8 minutes. Yeah, that is option A. So keep on practicing. We'll do many more problems. Bye.